Hello everyone, I'm Yuhang from DeepWise AI Lab. I'm glad to present our recent approach, cross-view correspondence reasoning based on bipartite graph convolutional network for mammogram mass detection. Compared with other medical data, cross-views of mammograms provide related and complementary information, which is helpful in clinical interpretation. Figure 1 shows the relation of cross-views. To exploit relations of cross-views, radiologists take the reasoning procedure explicitly. First, extract suspicious regions in the examining view, then search the regions in the auxiliary view with compatible locations and appearances. If reasonable regions are found, regions in both views are more likely to be matched and vice versa. Motivated by the reasoning procedure of radiologists in that paper, we propose a bipartite graph convolutional network to provide customized reasoning ability in mammogram mass detection and further enhances the features. The bipartite graph nodes represent relatively consistent regions in breadth, while the bipartite graph edges model both geometric constraints and apparent similarities of nodes. Correspondence reasoning enhancement, which is based on the defined bipartite graph, enables spatial features aware of corresponding regions by propagating information through nodes and further enhances the features. Figure 3 illustrates the architecture of the proposed BGN. There are three major steps. First, build bipartite graph node, then build graph edges, last, reason across correspondences. The goal of the nodes is to represent relatively consistent regions in breadth. It's intuitive to ask two questions: where to locate, what to represent. To answer the first question, we define pseudo-landmarks according to prior knowledge, each of which locates at a relatively consistent region in breadth. Figure 4 illustrates where each pseudo-landmark locates. To answer the second question, we define k-forward mapping phi k. Phi k puts an irregular region satisfying the property, and for any pixel in the region, the node is one of the k-nearest nodes. We can see in figure 4, the mapping degenerates to Voronoi grids when k equals to 1. As shown in the equation below, we obtain cross-view node features using phi k. Bipartite graph edges aim to reveal underlying relations between nodes, which can be characterized in two aspects: geometric graph and semantic graph. Geometric graph models geometric constraints induced by mammogram screening mechanism, while semantic graph models visual similarities between nodes. The equation illustrates the relation of these matrices. Geometric graph is a global statistic correlation matrix. To obtain the geometric graph, we link the nodes if they represent the same mass. Semantic graph is an instance-dependent matrix obtained by the following equation. Based on the bipartite graph, the goal of this step is to enable spatial features aware of corresponding regions and further enhance the feature representations. In the first step, we give the augmented form of the bipartite graph to adapt to the manner modern graph convolutional network. King reverse mapping projects graph node features to spatial domain, following the similar idea of phi k. We finally fuse with the original feature and obtain the enhanced feature. In the experiments, we first compared the results with several state-of-the-art methods. We can conclude from the tables that the proposed model outperforms state-of-the-art method. We also conduct case study and visualization. As shown in the right figure, each row shows a case. Column A to B refer to the examining view and its auxiliary view with annotations. Column C to D indicate detection results by mass RCN and the proposed method. We can see our method is better. Column E visualizes the attention area on the auxiliary view. We can see that bipartite graph focuses on the mass located area in the auxiliary view. Column F to G visualizes the response map. Before and after correspondence reasoning, we can see that feature response map activates more prominently on mass located area after enhancement. Thanks for your listening.